We're super excited to help you all here at Marco Learning. This is a really exciting event because this is the AP Statistics Review. We're going to be doing reviews in 18 subjects over the course of the next couple of weeks. So let us know in the chat which other AP exams you're taking this year and how we can help you as much as possible. We've done content live reviews. We've done reviews in a whole range of subjects. And tonight we're going to be spending just about an hour with you all going through AP statistics and making sure that you are all set up as well. So we want to know in the chat how many of you can just let us know to make sure that you can hear us and let us know that we know what topics are going to be the most helpful for you. So this is a really exciting event. Jennifer, you're joining us today from Texas. I'm joining from New Jersey. We've got people joining from all over the country. So I'm going to turn it over to you, and we will be going for about an hour, and we're going to post this to our channel with our hundreds of other videos for AP support right when this is over.
All right, thanks. Like you said, my name is Jennifer. I am from College Station, Texas, so home of Texas A&M. I'm going to go over AP stat test taking tips and strategies, and then we'll go over just a couple of exam questions, frequently missed exam questions, and kind of things to remember tomorrow. Okay, so just kind of the AP test breakdown. It's about a third, a third, a third. So for multiple choice, we're talking about collecting and describing data. That's anything from biases or interpreting stem and leaf plots or scatter plots. A third, probability and sampling distribution. That's binomial probability, when to use that. Sampling distributions, when we talk about law of large numbers, or z-scores, calculating z-scores and comparing z-scores. And then everyone's favorite, inference. So that's your T and Z test. Remember, T is for mean and Z is for proportions. So that's kind of your multiple choice breakdown. For your response, there are going to be 5 questions on one or more of the above topics. One investigative task, which uses multiple things. You might see, you're describing the data, talking about bias of an experiment, and then you're also running an inference test on it or something like that. And so that is typically our number 6. There are multiple parts to that. A lot of times they use vocabulary that you're not used to or you haven't seen. Roll with the question. We promise we are not asking you anything that you don't know or can't do. We may just be asking it in a different method. And we're really just looking, can you apply all of the knowledge that you have, that you've gained throughout the course, into this kind of new way? So anyway, that's the breakdown. Test format, the first part is going to be a multiple choice section. You'll have 40 questions. You have an hour and a half to finish that, and that's 50% of your score. Section 2 will be that free response, and there will be 6 questions. You also have an hour and a half for that, and that also accounts for 50% of the score. The multiple choice questions, kind of keep in mind, you should do about 2 minutes a question, maybe a little less. So some of them should be pretty quick. There may be some calculations that you need to make, but really they should go pretty quickly. There's not going to be any issues with skipping or not answering, although you should always try to answer the questions, right? So typically we tell students to just go through, answer exactly what you know, every question that you're 100% sure about, and then go back, eliminate unreasonable answers, and then always use context clues. If we've asked you about power in one way, we may ask you about power in another way. So kind of using those multiple choice questions to guide you in maybe questions you're not for sure about. For the free response questions, there are 5 questions that you want to spend about 12 minutes each on, and they'll have multiple parts. One investigative task, that's the number 6, and you'll use about 25 to 30 minutes on it. Like I said before, on that question 6, read the instructions well, be open to apply the knowledge in a new and unexpected way. That's what we're looking for. A lot of times, many of you can answer at least half of that question 6 based on things you know. And it's usually just that back end, that last part of question 6, where we're asking you to apply it in kind of a new and unfamiliar way. Okay, so for free response questions, and that's kind of why I'm here, right? I grade those free response questions every summer for College Board. that's one of my jobs. I've had that job since 2017 when I was an AP Stats teacher. You get 4 possible points for each question, for each of those 6 questions. And then we rank each part of each question as either essentially correct, partially correct, or incomplete or incorrect. And then we total those parts together and give you a score for that question. Then all 6 questions are added together, and that's part of your overall score for your AP exam. So here's some stats for AP Stats, because why not, right? Just so you guys know, in 2023, 60% of the students received a 3 or higher. So you guys have a high probability of doing pretty well. 15% of the students received a 5, and that's usually good enough for college credit in most of the colleges that accept AP Stat as an equivalent for their intro statistics course. 22% received a 4. The number of colleges accepting AP Stat was 2,625. And top 8 schools taking AP scores: UT Austin and Texas A&M University. That's where I work right now. So those were the top 2. University of Florida, UCLA, UC Berkeley, Purdue, and University of California, San Diego. Also University of Michigan, Ann Arbor. So if any of those are kind of on your list, they take them. They take all those AP scores. So it's good to know. Okay, so let's get started. So for tonight, and I know that John is going to be kind of reading your chats, and he might give us kind of some guidance about halfway through on maybe some questions that you guys really want to know. I'm going to give you kind of an outline of what I thought was really important to go over today, and then we'll start. So what I did is I went through the last 3 years of testing, 3 or 4 years of testing, and I looked at the lowest scoring questions. Okay, so last year it was number 4, which was an inference question, and that's actually what we're about to hit. The year before that, it was number 5, which had a multi-focus, and we'll do that at the end if we have time. In 2021, it was actually number 2 and number 3. Number 2, the average score was 0.92 out of 4. So not really many people did well on it. That was about collecting data, which is something you learned in the fall, right? Like a long time ago. So we're just going to revisit that question. And then also it was number 3, which was probability and sampling distribution, which you probably saw at the end of the fall semester if you did a whole year for your AP Stat class. That one, the average score was 0.73 out of 4. So people didn't do well on it. So I just want to talk about some things that people frequently miss, and how you can really collect some of those points that are really important to collect, little nuances that we are looking at as we grade to kind of give you a leg up on the competition. Okay, so let's start with this one. For each patient, it says, there were some scores. So we were talking about irritability scores, and we were giving them a placebo or an omega-3 drug. Okay, there were obviously 19 people that we were giving this to earlier in the question, which I didn't include just for space. It said that we gave them either or. They were randomly assigned a treatment, either the placebo or the omega for a week. Then there was a week off, and then we switched the treatment to be the one that they did not receive that first week. Okay, and then these are the results. So this is kind of the information they've given you. So they've given you the mean, the standard deviation for the placebo, omega-3, and the difference. They also gave you box plots, just kind of seeing what they gave us. Okay, so here is our question. It says, the researcher claims the omega-3 supplement will decrease the mean irritability score of all patients with medical conditions similar to the volunteers who participated in the study. Is there convincing statistical evidence to support the researcher's claim at a significance level of alpha equals 0.05? Complete the appropriate inference procedures to support your answer. Okay, so what I'm going to do is I am going to give you this information. So we're looking for alpha level 0.05. We're looking for the appropriate inference procedure. I'm just going to go back and give you this. And I just sort of want you to think about what exactly we are asking and how you would approach this problem. So I'm going to give you about a minute and a half to kind of think about it, and then we'll go over exactly how you need to set up these type of problems, these inference problems. Okay. So when I was teaching this type of question, I sort of had my students set up areas on their paper. And really, I did that just for memorization. So if your teacher does it a little bit differently, that's fine. I just want you to make sure that you hit all of the things, okay? So a couple of things. They said, is there convincing statistical evidence? That right there is telling us that we have to either run a test or we have to do a confidence interval. Likely it's a test when they give us alpha levels. So that's what I'm going to run with. For whenever you're doing inference, there are a couple of key parts to this. You must tell us what type of test you're doing. So you see I have the test name written over to the left. I'm doing a one sample t-test for means. It needs to say t, it needs to say means, it needs to say one sample. It could be a difference, that's fine, but it needs to be, even if you're talking about a difference, you're still doing a one sample t-test. So that is important. The other thing it must have is conditions, and we'll talk about those in a second. It must have your null and alternative hypothesis. The test statistic and the p-value both always have to be included. And then your conclusion has two parts. It's going to have a conclusion, which is comparing alpha level to p-value. And then it's got to have, what I used to say is, how do you explain that? Like if your mom was asking you what the conclusion is, how would you explain that? You wouldn't use a p-value and an alpha level. You would just say, what does it mean, right? In context. So the conditions, we'll start with those. The conditions that we are primarily concerned about is independence and approximately normal. So for independence, we need it to be randomly selected. So it must say randomly selected somewhere in there. And usually it does, almost all of the time it does. We just need you to address that, right? So you guys didn't see that original part of the question because I left it out. But what it said is, in quotes, and I quoted it, patients took a randomly assigned treatment, okay? And so that's all you have to say. Find it wherever it is. If you underline it or highlight it or whatever you're doing on the test, that's excellent. You just need to make sure that you address that in the down at the bottom where the work is, because that's what we're looking for. So you would say random, and then you could say question states they were randomly assigned to treatment, or you could actually quote it, which is totally acceptable. The other thing, and we don't quite look at it, but I don't want to tell you not to do it because we have looked at it for grading before. So this just little n has to be less than 10% of the big N, right? That's just your sample size should reasonably be less than 10% of your population. So 19, which was our sample size, is likely less than 10% of all the people with this medical condition. The other reason it's really important to put that is because that's a way to put context in there in case you miss it somewhere else, right? And so our context is that this is a population, this is people with this medical condition that we're concerned about. Approximately normal. So I know you guys have done sampling distribution, and what you're normally looking for is greater than 30, right? NP, if we're talking about proportions, has to be successes and failures, has to be greater than 10. If we're talking about means, it has to be greater than 30. Well, this sample size is not greater than 30, right? Shocker. So here's what they really wanted you to see. They wanted you, and this is why they added it, they wanted you to look at these box plots and see there's no outliers. There's not some like really obvious skew. And by obvious skew, I mean that my median is really close to either my Q3 or my Q1. For these, my median is relatively centered within the distribution. And so that's all they're looking for. We're not expecting you to be like brilliant statisticians. We're just expecting you to have a general idea of what this box plot looks like, and that the median should be generally centered within the box. There are also no outliers. Those would be indicated with little stars or dots on these outsides, and there are none of those. So even though my N is less than 30, my box plots indicate an approximately normal distribution. That is excellent for approximately normal. You had to have both of those in order to get that part of the question correct. Then my hypothesis with populations defined. So here's where kids get a lot of points taken off, is they either won't actually specifically write the null, the HO, or the HA, the alternative hypothesis, or they'll use a sample statistic because that's what we're using to kind of estimate this, right, is X bar. They'll use a sample instead of a population. One thing to remember about inference is we are always taking a sample and estimating a population. So for my null and alternative, I'm trying to estimate for the population. So those have to be population statistics. So it has to be a mu for means. And it has to be a big P for proportions versus a P hat, which would be your sample proportion, or it has to be a big B, like a beta, if we're talking about estimating slope. So whenever you're doing a null or alternative hypothesis, those must be my population symbols, not my sample symbols. My null hypothesis is always going to be equal to whatever the no difference is or status quo is. And then my alternative here, because of the way they said that the subtraction happened, so they said the difference was placebo minus omega. And so we were looking for a reduced irritability score. So we were looking for my omega to give me a smaller score than my placebo. So my difference should be a positive number or greater than 0. So that's why my mu D is greater than 0. In words, if you were going to put it, the difference when subtracting placebo minus omega needed to be positive. Okay. Once all that's done, you can calculate all of this in your calculator if you want to. I didn't actually write the formula out here. You 100% could write the formula if you wanted to, if you are familiar with doing it by hand. When I taught it, if we could use the calculator, I let students use the calculator. So once you do this, again, this is a one sample t-test. So it would be stat, it would be test, it would be one t-test. And then once you put in your mu naught is 0, I'm testing for greater than, and then my X bar, my sampling mean difference is 1.789, and my sample standard deviation is 2.485. Once I put all those things in there, I get a t-value of 3.138. Now, if you're familiar with the normal curve, the t-value or the t-curve is very similar, right? And so if we get outside of that range of 3 and -3, we're talking about really small probabilities. Kind of remembering that as you're looking at these inferences, your p-value should make sense, okay? So if I have a t-value of 3.138, I'm kind of out on this tail, my p-value should be really small. My probability should be really small. And it is, it's 0.0028, okay? So those two things must be included. Conclusion with context. So I always required 2 sentences when I was teaching this. The first sentence was specific about p-value and alpha level. The second sentence was, what does it mean? Or how would you tell your mother this? Okay, so because the p-value of 0.0028 is smaller than the significance level of alpha equals 0.05, we will reject the null hypothesis. That gives you part of the conclusion answer, okay? So you would get a partially if you just put that. To get that E, which is what we're all shooting for, right? To get that excellent answer, you need to tell me in context what that means. There's convincing statistical evidence to claim that the mean difference in irritability scores, and I'm just going to mention it, you didn't have to, but placebo minus omega is greater than 0, indicating omega-3 may reduce irritability scores for patients similar to the ones in this study. Okay, so that's just indicating that it will reduce the irritability scores. That's how we would describe this to a doctor. So the next slide, I just sort of gave you how we scored this. We scored it in 3 parts. The first part was part 1, and it had 4 sections. 1A was you had to define the test, okay? B was you had to define that it was a mu, not an X bar, not a P. C was that you had to have that it was null was equal to 0, and the alternative was greater than 0. So that's what we were looking for that third part. 1D was actually context. So I had it, as long as you had it in your conclusion or somewhere in here, that counted. You didn't have to have it up on hypothesis. If you did, great. If you didn't, we were able to select it even if you just had it in conclusion. For the second part of this, you had to talk about the conditions, randomly selected, and then approximately normal. And here we were really wondering, can you read that box plot? See how we stuck that in there, right? That describing distributions. Could you read that box plot and go, okay, it looks kind of reasonable, right? And we could do that with a scatter plot. We could do that with a bar chart or a histogram. We could do that lots of different ways. But just kind of being open to remembering that you can see whether it's approximately normal in lots of different ways, not just a big sample size. For 2C, we needed you to actually describe the T, and 2D, we needed you to actually put in the p-value. Notice you didn't have to use the formula. You didn't have to tell me that you ran the test on the calculator. You could, that would be fine, but you did not have to. And then part 3 was the conclusion, and it was only 2 parts for that part 3. The first part was specifically comparing p-value to alpha level, and then the second part was in context. What does that mean? And all of the time, 100% of the time, when we grade inference, we are looking for those 2 things. Did you compare P and alpha level, right? Reject the small p-value. If this p-value is less than alpha level, you're rejecting the null hypothesis, okay? So that's the first part. And then the second part is context. You have to make sure you have those 2 parts whenever you're doing inference, okay? All right, so moving on, and I know I'm going super fast and I'm sorry about that, but I want you guys to get as much material as possible in this kind of cram session, last minute cram session. Okay, number 2, so it's talking about conducting a year-long investigation of walking and cholesterol levels in adults. They have a random sample of 100 adults from a target population, and they are just talking about recording activity, and then they're going to measure cholesterol, okay? So I'm just going to give you 2 minutes. I want you to read these. You don't have to try all of them. But this is the entire question. I didn't leave any of it out. But I'm going to go over all 3, A, B, and C, but I'll give you 2 minutes. Just read it and see what you think. And then we're going to go over all of the answers in this. And there is, as you can see, there is not any math in this one at all. This is all the specific words we're looking for. So I'm going to give you 2 minutes. Okay, hopefully that gave you a little bit of time to read this question. And then I'm just going to kind of go over what we were looking for. Part A says one aspect of the study is to record the number of miles each subject walks per day. The researchers are deciding whether to have subjects wear an activity tracker to record the data, or to just have subjects keep a daily journal of the miles they walk each day. Describe what bias could be introduced by keeping the daily journal instead of wearing the activity tracker. So hopefully you guys read that and we're like, obviously that would create bias. Like there's no way that people are going to track it correctly. And most people do have that reaction. Here is the issue, is that a lot of times when you guys are on this test, you're getting a little nervous, you know that, but then you're like, oh, maybe I need to describe both or neither. I don't really know how to describe this. Here's my advice. Pick one method, pick it. They either they want you to believe that they really work out, and they believe that they're truly fit, and so they're overestimating how much they're doing activity wise, or they just truly can't remember, and so they grossly underestimate how much they have activity. We don't care. We will accept both. We want you to pick a method and then tell us what bias is introduced. So for this, bias could be introduced, and I just picked that we obviously can't remember. So I'm going to say that I think I'm fit. So I'm like, I walked from my car to the building, and then I walked upstairs. I mean, that's got to count for activity, right? So I picked that method, right? Bias could be introduced by keeping a daily journal because people tend to forget actual events of the day. If someone thought that they were being super healthy and active, they may report their daily activity, whereas an activity tracker wouldn't produce any bias because it is simply recording the activity. Okay, so I don't care which one. You could pick either one. Either they overestimated or underestimated. So that's one of the things you had to answer. Here's the part that students always miss. Always, always, always miss. If people consistently overreport activity, this could lead to a sample that doesn't truly represent the population. If you write anything down from tonight, please write down that sentence or take a picture or something. We always, always are looking for how does that affect what we're looking for, right? You're always trying to estimate for the population. That is the point of statistics, right? We don't know the population. We can't afford the census, right? We can't do it because of time or price or whatever. And so we're always trying to estimate for the population. So you need to address the bias that could happen, how it could happen, right? They can't remember. They could just flat out lie. You need to pick one way or the other. I don't care. They overestimated or they underestimated, but pick one method and stick with it. And then that last sentence, if people are consistently over-reporting activity, then it would be not representative of our population. Okay, you have to put that. That's always what we're looking for, is the connection to, does it represent the population? Okay, so part B says selecting a random sample creates a reasonable representative sample of the target population. Explain the benefit of using a representative sample from the population. So that right there, I mean, the first time I read it, I was like, obviously you need a sample representative of the population. I'm not quite for sure what we're looking for, right? It's actually exactly what we're looking for. The benefit of using a representative sample from the population is it allows you to make an unbiased inference, okay? So things that we were looking for in this one, and I think this is why it was so low scored, is because it's so vague. We were looking for the fact that you need it to be a representative sample so that you can do inference, so that you can make inference. And you need it to say something about regarding the target population, okay? And the context of what we were doing. So increasing activity and how that affects cholesterol levels. So we were looking for, you need it to be representative so that you can run inference regarding the target population, regarding the population on the effects of activity for cholesterol, okay? Again, that was super vague, and I think that's why people got really hung up. They didn't even know how to start with that. But if you think about it, we do need it to be random, right? And we do need it to be a representative that kind of matches what we're looking for so that we can do those inference. That's the whole point of statistics, so that we can run a confidence interval or a test to see if this really does affect or work or whatever. So that was part B. Part C said, suppose the researchers conduct the test and find a statistically significant result. Would it be valid to claim that increased walking causes a decrease in average cholesterol levels for adults in the target population? Explain your reasoning. Okay, so when I was teaching, when we talked about cause and effect and what could do cause, we always said a well-designed experiment, right? A well-designed experiment is the only thing that can prove causation. And it really doesn't prove it, it just suggests it, right? Or never really for sure. There's a guy, a famous statistician that says no models are correct, but all models are useful, right? And so we are not 100% ever correct in statistics. We are just using what we know to kind of predict for the population. So would it be valid to claim that increased walking causes a decrease in average cholesterol? So as soon as you see that word cause, I hope tomorrow on the test, as soon as you see that word cause, you think, is this an experiment? And you go back and read the question. It said they're doing a year-long investigation of walking and cholesterol levels. They're going to randomly select 100 adults. And then they said they're going to record the number of miles. But for it to be a well-designed experiment, doesn't it have to have a treatment? Doesn't it have to have a couple of different groups, right? I need to compare things. I don't see that. I'm really just looking at whether they walked, and as they walked, did it decrease the cholesterol? So with that in mind, it does not, okay? It does not prove causation. And so what we were looking for here is for you to say that in order for it to prove causation, it had to be an experiment, okay? So the way I answered it, because a causal relationship can only be determined by a well-designed experiment, researchers would not be valid in making this claim. There are no randomly assigned treatments to the subjects. So all we were looking for there is, did you say that the answer is no? Okay. No, you cannot do a causal relationship. And then we were looking for you to describe something about an experiment. So I said randomly assigned treatments. You could have said there's no, you could have said a couple different things, but you had to either describe an experiment or you had to specifically say it wasn't an experiment. You could have also said that this is an observational study, not an experiment. That would have also been okay. We would have accepted that answer. But you had to say no. And then you had to say that it's because it's not an experiment. And you had to either describe why it's not an experiment or specifically say it's not an experiment. So either one of those would have been okay. Okay, moving on. Man, we're getting through a lot. It's so good. Okay, this is number 3 from the 2021 exam. So this one specifically was probability and sampling distribution. It had the lowest score of all the ones we've gone over tonight. It was an average of 0.73 out of 4. So people did not do well on this one. Hi.
Hey, everyone. Actually, before we jump into this number 3 that everyone seemed to have bombed, Jennifer, I just wanted to share with you one question I've been seeing kind of run through the chat. And hi, everyone. I'm John from Marco Learning. One of the questions I have for you, Jennifer, is if I'm taking AP statistics tomorrow and I want to go somewhere online to see how to use my calculator or kind of just double check how I'm using some of the features for AP stats. Is there a really good website for this or a YouTube channel?
Oh gosh. That was something I covered as a teacher, so I didn't really use any YouTube. I will tell you hopefully you guys all have a TI-84. That is my tried and true. I will tell you all of your tests and all of your confidence intervals, and you can write it down and maybe you can type it in the chat or give these guys. It's going to be stats. So you're going to hit the stat button. You're going to arrow over to test. And that's going to have all of your tests. So that's your t-tests, your z-tests, your proportions. That has all of your tests in there. So if we are asking you to give us a result, a t value and a p value, you can get it off your calculator. Now, that being said, every formula that we will ask you for is on the formula sheet. So you can always use those. But if you want to use your calculator, it's going to be under stat, and you're going to go over to test, and that's all of your test. So that's for inference. Don't be stressed if you don't know how to do that, because there's inevitably going to be an inference question regardless. But as you'll see later on, some of the inference questions, we actually give you all of the information, and we just ask you to make a decision based on the information. So calculating inference there's not a huge, we're not usually asking for a huge amount of information from you. We're really just wondering, like, do you know what to do about that? Like, how can you apply inference in that situation? So if you don't know how to use your calculator, don't worry about it. It'll be fine.
That's great. That's great to hear, Jennifer, because I don't know how to use my calculator. And so I put in the chat stat test as a reminder. And I asked everyone kind of what calculator. It looks like we got a lot of the TI-84, vibes are strong in our in the chat tonight. So we got a lot of TI-84 people, and that's a really good starting point for everyone. And I think there's that reminder that you've got that formula sheet as well. So what we're going to do, everyone, real quick, is I'm going to give Jennifer a chance to guide us through question 3 here. We can maybe go a little bit after our scheduled time. If you like this video, press that like button. Definitely remember, we're going to be doing lives in 18 subjects. I think this is our 3rd of the 18. So stay tuned if you're taking other AP exams. But Jennifer, I'm gonna come back into the chat. And at the end, if everyone's well behaved, we'll bring Marco out for a little bit of like words of information from my dog. So I'll let you and everyone tackle this really fun, really difficult question 3, and we'll keep working through.
Okay, thanks. All right. So like he said, we'll go through it. This specific question is about probability and sampling distribution. I promise we will have a question like this. We always do. Typically, it's a binomial question because we want to know, do you know binomial distribution? So as I go through it, I'm going to give you a couple of just sort of tips and tricks, because when I grade these type of questions, there are consistent things that students miss, and I have to take off for that. And I don't want you guys to be a part of that group, right? So we'll walk through it. So it's saying, to increase morale among employees, the company begins a program where one employee is randomly selected each week to receive a gift card. Each of the company's 200 employees are equally likely to be selected each week, and the same employee could be selected more than once. So what that's telling me is that I select 1 out of 200 each week, and that probability doesn't change. Okay, I just put their name back in the hat, and I can draw again next week. Which is nice, right? My probability is not changing per week. Okay, so each of the company's 200 employees is equally likely to be selected each week. Each week's selection is independent from every other week. Again, that's important for what we're doing. Consider the probability that a particular employee receives at least 1 gift card in a 52-week year. Define the random variable of interest and state how the random variable is distributed, and then determine the probability that a particular employee receives at least 1 gift card in a 52-week year. Show your work. Okay, so we're going to start with part A, and then we'll move on to part B and C, and I'll just kind of talk through them as we go to them. So part 3, we're looking for a lot here, and it doesn't feel like a lot because of the amount of space that we gave you. I feel like sometimes students look at the amount of space and they're like, oh, they only want 2 words. Define the random variable of interest. That can be in words. And basically the random variable is we're looking for the distribution of the number of gift cards an employee will receive. Okay, so you need to have gift cards. You need to have that they will receive, that the employees will receive them. So you need to have the context of that. And then you also need to talk about that it would be a binomial distribution. And what indicates that it's a binomial distribution are there are 2 choices. You either receive a gift card or you do not receive a gift card. And in life, a lot of probability is binomial, right? A yes or no. Very few times do we have ordinal, and we've never experienced ordinal on AP stat, right? That's college stat. So So the random variable of interest is the distribution of the number of gift cards an employee receives in a 52-week year. So that's kind of the expected answer. But again, if you said gift cards that an employee receives within a year, that would have been fine. But you needed to have that it was also a binomial distribution. Okay, and then determine the probability that a particular employee receives at least one gift card in a 52-week year. So here's where people mess up. If they know it's a binomial probability, they might just give us an answer, right? 0.2295. And that'll be all they give us. And I can't give you credit for that. So if it's a binomial probability, you need to have things, right? You need to have the number of trials, you need to have the number of successes, you need to have a probability. So I put all of these things here. You don't have to have all of it, but I kind of want to explain. If you say it's a binomial distribution, I want to know the probability that I got at least one, so greater than or equal to one, out of 52, and my probability is 1 out of 200. All of that would be great. I would totally accept all of that as the pieces that I need to show me that you know what you're talking about. Or you could use this, which the B means binomial distribution, with 52 as my number of trials, and then 0.005, which is that 1 over 200 as my probability. Or you could do a binom CDF. And I will say, here's the thing. A lot of kids do binom CDF because they know that function in their calculator. They've been taught that function. That's great. The problem is binom CDF, a lot of students will just write 52, comma, 0.005, comma, 1, comma, 52, or whatever, okay? They won't write my N or my P. They won't write what I'm looking for. So if you're going to do a binom CDF, if you're going to actually have that script written out, you need to either write above or near or inside the parentheses what everything means. I know when I do binom CDF in my calculator, it actually comes up with a list and it says trials and samples and things like that. So I can enter it that way. If you want to write it that way, that's completely fine as well. We just need to know that you know what the numbers are. The other tried and true method is to write the formula. And so this will always be accepted. This is the probability that I'm getting more than one, at least one success, which the easiest way to calculate that is 1 minus the probability that I get no successes. And so that is the formula that they're looking for. And then this is my actual binomial formula from my formula sheet. Again, if you do that in your calculator, you will get the 0.2295. So you can see there were lots of different parts here, and the actual answer isn't worth very much. So if you get the answer, great, but you have to tell me that it's a random variable. You have to give me context. You have to give me that it's a binomial distribution, and you have to give me my trials and my sample size and my probability. So lots of information that I need to give you credit for that one. Okay, the second part of this was calculate and interpret the expected value for the number of gift cards a particular employee will receive in a 52-week year. Show your work. So on your formula sheet, it gives you binomial distribution. So if you got that far, great, but then it only gives you mean and standard error. If you don't know that mean is the expected value, you won't know how to calculate this. So I wrote that on there. You don't necessarily have to write that expected value is mean, although it's not going to hurt you to write it. And it tells me as a grader that you really know what you're doing, okay? So if the expected value is the mean, then this is the formula. Mu of x equals NP. Now, to give you credit for this, I did need to see that. I had to see the formula that you used. Then you had to identify again NP, and then you had to do the calculation. So for this, calculating was 2 parts. I needed the formula from the formula chart, and then I needed the actual calculation. The interpretation then was also 2 parts. I needed you to tell me what the value was. I needed you to mention that it was an employee, and then that was the expected number of gift cards. So I needed you to say context. And then I needed you to say on average. So that's the mean, right? That's telling me on average. So each employee can expect to receive 0.26 gift cards per year. Okay, well, what does that mean, right? If I'm thinking about it, it's a quarter a year, so maybe one every 4 years. So that was the extension I made there. That is, you do not have to do that, but if it helps you to round to a whole number and then give out of a bigger number, then that's totally fine. And I feel like this, as far as context goes, makes more sense, right? If I'm doing this program, 0.26 gift cards out of a year doesn't mean anything. But if I say, look, if we do this program for 4 years, you're likely to get a gift card once out of those 4 years. That makes sense to people. People can understand that probability. So again, I needed on average, I needed the actual probability that you found up here, and then I needed context. So 2 things that I need to tell you. If you calculated it incorrectly up here because you didn't know what expected value was, or you guessed and you got 0.3 or 0.5 or whatever, I would follow that number down and you could get 100% of your answer. I could give you an E on this part, on the interpretation, if you used the value that you found in the first part to describe the second part. So if you are afraid that you didn't get the calculation right, or you're nervous about the numbers, just keep using them, okay? We will follow your math. We know that math is not always everybody's strong suit. A lot of kids that take AP Stat also took calculus, are also doing 100 different things, and we get it. There are mistakes that are made in the calculator. That is fine. We want to know, can you take that number and can you interpret it? Because that's what really we care about in statistics. So even if you got a number that you're not really 100% for sure about in this expected value, follow it through and then give me the answer in context of what I'm asking. And then you can get full credit for that. Okay, part C said, suppose that Agatha, an employee of the company, never receives a gift card for an entire 52-year based on her experience. Does Agatha have a strong argument that the selection process was not truly random? Explain your answer. So in my head, before I even answered this question, I was like, the probability is 0.26. Like, no, she has more of a probability of not receiving a gift card in a year than she does of having a gift card. So then I just sort of had to think about how to put that into words, right, that are going to give me full credit. So this is what I did. First of all, I answered the question. Remember, I told you students always forget to just answer the question. I need you to answer yes or no. Agatha does not have a strong argument that the selection process was not truly random. I am really just using verbiage from the question, but I am answering the question. That's the important part here. Agatha does not have a strong argument that the selection process was not truly random due to the expected probability of receiving a gift card is only 0.26. And then I also put that, or 1 gift card every 4 years, just because that made sense, right? It is reasonable that she would not receive a gift card in the first year of this program. So what we were looking for here was, number 1, did you use 0.26? Did you use the expected value in your justification of it? Did you use context? So did you say gift card and per Agatha or per year or whatever? And then did you answer it correctly? Did you say no or yes? Okay. If you don't answer that question, we can't, that's half of your score right there. So we can't give you those points if you don't answer us. So just so you know, that's kind of all I have for you guys. I do have more questions, but I don't think we're going to get to them. A couple of things I want to just tell you. You're not gonna learn everything tonight. You're not gonna cram and learn everything tonight. But going ahead and reviewing your formula chart and kind of reminding yourself of, all right, if I see this type of problem, then I'm looking at proportions, and then here's those formulas. If I'm looking at means, here's those formulas. Remember, for confidence intervals and for tests, we don't actually give you the formula. We give you in words the verbiage of what it is. So we say test statistic plus or minus your Z or T star times the standard error. So it's up to you to go down in that formula chart, find standard error and plug it in, and find test statistic and plug it in. So just kind of make sure you're familiar with your formula chart. Make sure you know your Z and T scores and what those look like, where they are at in your formula chart. I guarantee there'll be a binomial. I guarantee there'll be some inference. But again, it's not all about the math with inference. A lot of times it's, can you interpret? Can you tell me what that means? One of the other things that people a lot of times mess up on is if they get a p-value. Let's just make sure we are all on the same page of this. Probability can only be between 0 and 1, right? So if you're doing something on your calculator and you get a probability of 8.246, there is no way that that can be probability. A lot of students forget to look at the very end of that line, and it's telling you e to the negative something. So it's actually a very, very small number. It's a decimal. So remember your t, if your t value or z value is much greater than 3 or 4 or 5 or 6, then your p-value should be really, really small. So just kind of remembering those context things. Other than that, take a deep breath, eat some good lunch, and good luck.
Jennifer, I love this advice, and it's been a great group here in the chat. You guys have been amazing. I think that this advice about what you can actually do the night before is really, really critical. Somebody had a really great comment in here, which was, no, you're supposed to tell me I can learn my entire course and get a 5 3 hours tonight. Lol. So that could be a lie that we sell you. We're just going to tell you all the truth instead. And the truth is that the work you've been doing for months and months is something you're going to cash in on tomorrow big time. Right. And another thing I think that's so important to really emphasize on this exam and on all of them is lower the bar of the kind of perfection that you have in your head, right? When you get something wrong, when you freeze because you can't remember something, when you try it in your calculator and it ain't working, steer your ship around those kinds of moments, because if I were facing any AP exam, I would not try to get a perfect score. I would try to get a 4 or 5.
Right.
Very, very different thing. And I don't know exactly what the percentages are in statistics, but it's not anywhere close.
It's not 100. No, I think it's like an average of a 75 or 80 will get you a 5. Like, we're not looking for perfection. We're really looking for, do you know statistics? Do you know it well enough that we can give you college credit? You don't have to be perfect. You just have to know it well enough. So, yeah.
That is so true. And now it's really important that we have a special guest speaker. So if you can go ahead and stop screen sharing for just a minute, okay. Yes, Jennifer, we're going to bring on the hero of Marco Learning, who is Marco himself. And he's come in to a lot of our live reviews and said hello and done a little like wave and a little blessing for everyone. So in the chat, everyone, give me a little fluffy cloud or a little sheep emoji, just because Marco's here rooting for you and he is going to get a 1. So just do better than him, because his little paw, when you put it on a TI-84, it just mashes all the buttons together. So Marco says, hi. And Jennifer's wondering what happened with her life that she is waving to a dog live on YouTube the night before these statistics. And what happened is Marco Learning. So, and you can see actually in the chat, it's a lot of lovely puppies and sheep and clouds and a lot of disappointed people because it's back to me. So listen, everyone, I want you all to go in tomorrow, rely on the expertise of your teachers who've helped you through the year, rely on that TI-84, your best friend. Marco loves it. And rely on your own good sense as you steer through all of these things. So best of luck on your exam. We look forward to seeing you all at other reviews.